Good day everyone, my name is Edleen Galacgac from BSE 3B. Our lesson for today is Visibility Rule. Visibility rule or visibility tests helps one to check whether a number is divisible by another number without the actual method of division. If a number is completely divisible by another number, the quotient will be a whole number and the remainder will be zero. It basically means that using these rules of division procedure will be easier and quicker just by considering the digits of the number. Divisibility Rule of Two. If a number is even or a number whose last digit is an even number, it is divisible by 2. For example, 24, 508, and we all know that 8 is divisible by 2, and 1124, since 4 is divisible by 2, and so on. To check whether the number is truly divisible by 2, take the last number. For example, 1124. The last digit is 4. 4 divided by 2 is 2. Since the last digit 4 is divisible by 2, then 1124 is divisible by 2. Divisibility rules of 3. Divisibility rules of 3 states that the number is completely divisible by 3 if the sum of its digit is divisible by 3. For example, 627. To know if it's divisible by 3, you just have to add the sum of 627. So 6 plus 2 is 8, plus 7 equals 15. And since 15 is divisible by 3, therefore 627 is divisible by 3. Divisibility Rule of 4. If the two digits of a number are divisible by 4, then the number is a multiple of 4 and divisible by 4. For example, 1216. Considering the last two digits, 16, 1212 is divisible by 4. Another is 1008. Since 08 is divisible by 4, therefore 1008 is divisible by 4. Divisibility Rule of 5. This is very easy. If the last digit of a number is 0 or 5, then the number is divisible by 5. For example, 2570 or 385, 1000 or 10,000, and etc. Divisibility Rule of 6. Numbers which are divisible by 2 and 3 are divisible by 6. That means that the last digit is even and the sum of the given number is a multiple of 3. For example, 630, the last digit is 0, which is divisible by 2, and the sum of the given is 9, which is divisible by 3. Therefore 630 is divisible by 6. Divisibility Rule of 7. Compared to the first 6 rules, Divisibility Rule of 7 is more complicated. You have to remove the last digit of the given and double it, then subtract from the remaining number. If the number is 0 or recognizable two-digit multiple of 7, then it is divisible by 7. If not, you have to repeat the process. For example, 1221. The last digit is 1, so 1 minus 122 is 121. Since the last two digit is 21, which is divisible by 7, therefore 1221 is divisible by 7. Another example is 7,341. The last digit is 1, so 734 minus 1 equals 733. Since 33 is not divisible by 7, we have to repeat the process. So the last digit of 733 is 3, so 73 minus 3 equals 70. Since 70 is divisible by 7, then 7,341 is divisible by 7. Divisibility rule of 8. If the last 3 digits of a number are divisible by 8, then the number is completely divisible by 8. For example, 26,344. Since 344 is divisible by 8, then 26,344 is divisible by 8. Divisibility rule of 9 is if the sum of the number is divisible by 9, then the given is divisible by 9. For example, 1,988. So 1 plus 9 plus 8 plus 8 equals 27. Since 27 is divisible by 9, therefore 1,988 is also divisible by 9. Divisibility rule of 10. This rule states that if any number ends with 0, then it is divisible by 10, such as 100, 500, 200, 230, and etc. Divisibility rule of 11. If the difference of the sum of the alternative digits of a number is divisible by 11, then the number is divisible by 11 completely. For example, 2,189. First, you have to group the alternative digits, which are the odds and even. Then we will get 28 and 19. Take the sum of each number. So 2 plus 8 equals 10 and 1 plus 9 equals 10. Now, the difference of those numbers, so 10 minus 10 equals 0. And since 0 is not divisible by 11, therefore 2,189 is not divisible by 11. A few more conditions are there to test the divisibility of a number by 11. Number 1 is, if the number of digits of a number is even, then add the first digit and subtract the last digit from the rest. For example, 3,784. The number of digits is 4. Now, 78 plus 3 is the first digit, minus 4, the last digit, equals 77. Since 77 is divisible by 11, then 3,784 is divisible by 11. Number 2 is, if the number of digits is odd, then subtract the first and the last digit from the rest. For example, 82,907. The number of digits is 5. Then 290 minus the first digit, 8, minus 7, the last digit, equals 275. Thus, 8,207 is divisible by 11. 3. Form the group of digits from the right end and digit from the left end, and add the resultant groups. If the sum is multiple of 11, then the number is divisible by 11. Example, 3,773. So the right end digit is 37 and the left end digit is 73. 37 plus 73 is 111. Then 1 plus 10 equals 11. Since 11 is divisible by 11, obviously, 3,773 is divisible by 11. 4. Subtract the last digit of the number from the rest of the number. If the resultant value is multiple of 11, then the original number will be divisible by 11. Example, 9,647. The last digit is 7, so 964 minus 7 equals 957, and 97 minus 7 equals 88. Since 88 is multiple of 11, then 9,647 is divisible by 11. Divisibility rule of 12. If the number is divisible by both 3 and 4, then the number is divisible by 12. For example, 5,863. So 5 plus 8 plus 6 plus 3 equals 21. 21 is divisible by 3. The last two digits is 63, which is not divisible by 4. Therefore, 5,863 is not divisible by 12. Divisibility rule of 13. For any given number, to check if it's divisible by 13, we have to add 4 times of the last digit of a number to the remaining number and repeat the process until we get the 2-digit number. Then check if it is divisible by 13. For example, 2,795. The last digit is 5, so 275 plus 5 times 4. 5 times 4 is 20, plus 279 equals 299. So 29 plus 9 times 4 is 36. 29 plus 36 equals 65. Since 13 times 5 is 65, therefore 2,795 is divisible by 13.